Hey everybody, this is Mr. Piercy, and we're going to be looking at some quadrilaterals where we're going to be looking at the characteristics to determine is a quadrilateral a parallelogram or not. So this follows the last example or the last lesson that we saw that we looked at where we said this is a parallelogram, therefore these things exist. And those things were that if a quadrilateral is a parallelogram, the opposite sides are both parallel and congruent to each other. The opposite angles are congruent to each other. The same side angles are supplementary to each other. And the diagonals bisect each other. Those are all characteristics of a parallelogram. Now what we're going to be looking at is we're going to turn it around. We're going to just say I have a quadrilateral, and we're going to be looking to see does it have the characteristics of a parallelogram. So we can say, well, yes, this particular quadrilateral is a parallelogram, or no, it is not. And that's what we're looking at here. We can look to see if I have a quadrilateral that has opposite sides parallel or congruent to each other. Well, that fits the characteristic of what makes a parallelogram. So I could say, yes, quadrilateral ABCD must be a parallelogram. Same thing with the opposite angles. If the opposite angles are the same, that is enough information for me to be able to say, well, this particular quadrilateral must be a parallelogram because that's when they have angles that are opposite of each other that are congruent. Now, taking a look at this example here, solve a real world problem. Not exactly the most challenging one, but it does have, its appropriate place here. It says, looking at the basketball hoop, the diagram that we have, explain why AD is always going to be parallel to BC. Now again, try not to pay attention to what the solution is saying. We don't really want to look at that right now. Okay. Now, what these things are doing, because we can take the basketball hoop and for kids that are really kind of short, we can lower it down a little bit so they can try dunking, or we could raise it up back to regulation or whatever we want to do. Well, the brackets that make up the frame of the backboard to the pole, those are fixed. They do not change length at all. Now we could, move a latch and raise it up and down, but even if we did, if we took it and we made it so where this came out and was parallel like that, well, this blue part and this red part, they're still the same. This red part and this blue part, they're still the same. So it still creates a parallelogram because the opposite sides are going to be congruent to each other, but the angles inside can change. Now the angles across from each other, because it's still a parallelogram, the angles will still be congruent to each other, but that's what we're kind of looking at here. So the side lengths themselves will be the same, and because of that, well, that's why I can really conclude that this is going to be a parallelogram regardless of how I adjust the backboard to its height. So moving on, this is the other two kind of characteristics. Now the one up at the top is a little bit new. This is not something that we saw in the last lesson, but however it is enough for me to be able to draw a conclusion that quadrilateral is a parallelogram. So we know if the opposite sides are congruent to each other, both pairs of them, then it must be a parallelogram. Here what we're doing is we're not giving you both pairs. We're only giving you one pair of opposite sides that are congruent to each other, but at the same time, we're also saying that they're parallel to each other. Well, that means the only time that can actually occur is if the both sets of opposite sides are congruent to each other. So if I'm telling you that one set of opposite sides are both congruent and parallel to each other, that's enough information to say that yes, it is a parallelogram. And the last one here is something that we did see in the previous lesson, is that if the diagonals bisect each other. So if I have a quadrilateral so before I said this is a parallelogram, therefore the quadrilaterals must bisect each other. Well, here I'm looking at them saying, oh, hey, look, these diagonals happen to bisect each other. That must mean that quadrilateral ABCD must be a parallelogram. So it's just the same idea, just we're using the converse of it now. So looking at here at example 2, we have the lights of a car that are shaped in this diagram here. How do I know that angle B and angle D have to be the same? Now again, don't try not to pay attention to the fill in the blank stuff that's provided for you. Let's just try and think our way through it. Well, looking at the diagram here, we know that the side BC and AD, that they are both they're parallel and they're congruent to each other. They're giving us that information in the diagram. Well, if I have a set of sides that are opposite to each other and that are congruent and parallel, then that must mean that the quadrilateral has to be a parallelogram. And if it is a parallelogram, then the opposite angles must be congruent to each other. So that's how we're going to think our way through the problem. Now, filling in the blanks with that knowledge, we know that these two segments are congruent to each other and parallel to each other. That was given to me. So that means it must be a parallelogram. Whether you actually try to say theorem 8.9 or not, that really doesn't mean anything to anybody. You would say, well, because these characteristics are there, the opposite sides are parallel and congruent, that means it must be a parallelogram. So that means that the opposite angles have to be the same, because that's another characteristic of a parallelogram. So where it says theorem 8.9, theorem 8.4, that literally means nothing to anybody, and I'm teaching you it from this chapter. If you tried explaining that to, say, another geometry teacher or a geometry student, you said, well, by theorem 8.9, they're like, whoa, what do you mean theorem 8.9? Explain it in, say what you mean. Don't try and say theorem 8.9. Use, well, because it's a parallelogram, we can say this, but whatever. So at this point, go ahead and pause the video and work out these two problems and see what you come up with. And when you're done, go ahead and hit play. Come back and check your work against mine, see if we agree with each other or not. All right, so let's see. Let's go ahead and check our work here and see how you did. So example or problem one, quadrilateral GHJK gives us these angle measurements. Find the measurement of angle K. Well, I know that from the previous lessons that the sum of the interior angles of a quadrilateral have to be 360 degrees. And so since they're giving us two of them, we can use that to figure it out. Otherwise, we could maybe just draw a parallelogram, okay, and see, is it a parallelogram? So I'm going to say, well, let's see, let's say G, H, J, K. So we know 55, and H is 125, and this is 55. So using the properties of the fact that the four angles have to have a sum of 360, I'm going to look to see, does this one give me 125 degrees also? And if it does, I can say both sets of opposite angles are congruent to each other, therefore it is a parallelogram. And that's exactly what we're seeing. And I really shouldn't have said that. I don't like that. Yes, it is a parallelogram because the opposite angles are congruent to each other. That's why it's a parallelogram. What theorem can you use to show that the quadrilateral is a parallelogram? Well, looking here, the segments that we have, these are diagonals of a quadrilateral, and the parts of the segment that make up the whole diagonal are congruent to each other. We got, that's 4 and that's 4, and looking at the other one, we would say that one is 7 and this one is 7. Well, the diagonals, they're bisecting each other. So that means, since I have diagonals that are bisecting each other, that only occurs when I have a parallelogram. So the book is asking us, well, that would be theorem 8.10, but the reason why is it a parallelogram? Because the diagonals bisect each other. That's what makes it a parallelogram. So now let's take a look here. We're, again, going back to the old trope of what we do in a lot of geometry is we're taking the concepts and, we're going to see, can you apply those concepts with, some algebraic expressions so you can set up and solve an equation to figure some things out. So what is the value of x that would make this particular thing a parallelogram? We happen to know that QT and ST are the same. So we know that at least PR bisects QS. So we know that. So what we don't know for sure is if PR is being bisected also. So we're saying, well, what would the values of x have to be in order to make that conclusion? So right now we're predicating the premise of the question that says, if these two, what would x have to be to make those two segments PT and RT the same? So that is what allows me to set up the problem. We say, well, the diagonals have to bisect each other, so that means these segments have to be the same. So that means I'm going to set up the equation that says 5x has to equal 2x plus 9, and I'm going to solve for x. Move the 9 or move the 2x over through subtraction, and we get 3x equals 9 divided by 3. So x would have to be 3. So the only time that QS would bisect PR in this case with the information that we have is if x happens to be equal to 3. And that would tell us that the segments would be 15 and 15. Okay. Now here, again, I don't want you to try to memorize the theorem numbers at all. You need to be able to explain it to me in natural language. Theorem 8.8 doesn't really tell me anything. However, if you tell me that I have a quadrilateral that has opposite angles that are congruent to each other, therefore I have a parallelogram, that lets me know you understand what you're talking about. Okay? So here we're going to get into coordinate geometry, which now we're trying to, make sure when we have a problem like this, where I'm giving you coordinates, giving you a graph, you have to be able to, use slope formula, distance formula, midpoint formula, something like that in order to be able to justify, well, we do have this thing for sure because that's what the math tells me. So we want to be able to show that we have a parallelogram. Now I can do this a couple of ways. I can do the distance formula 4 different times with the opposite sides and make sure that the opposite sides are congruent to each other. If I do, then I know I have a parallelogram. I can find one set of opposite sides and see that they're congruent to each other, and if those same sides are parallel to each other, we could do that one. So we're looking at doing, it looks like 4 equations one way or the other. I'm either going to be doing the distance formula 4 times for the 4 opposite sides, or for the 2 pairs of opposite sides, or I'm going to do the distance formula twice and the slope formula twice to show that I have a pair of opposite sides that are parallel and congruent to each other. However you want to do it, that's what you would do. Now, unfortunately, the way the problem is set up here in our notes, they're forcing us to say, if you're paying attention to anything, that we're going to do the distance formula and we're going to use slope, which is fine. However you want to do it. Either approach would be great. So looking here, theorem 8.9, that's the one that says that the opposite sides have to be congruent and parallel. That would make it a parallelogram. So that's what we're going to do. We're going to find the length of segment KL using the distance formula. Now again, ideally the distance formula that you have is memorized. So KL, when I work it out, is radical 8 or 2 radical 2 simplified. And MN is radical 8 or 2 radical 2 simplified. So we know that we do have one pair of sides that are opposite of each other that are congruent. So do they have the same slope? Because if they do, that means that we do have a parallelogram. So the slope of KL is 1, and looking at here, when I plug in those numbers, that also gives me a slope of 1. So my conclusion would be, yes, this quadrilateral is a parallelogram because I have a pair of opposite sides that are congruent to each other and parallel to each other. That would be the explanation that I would expect you to tell me, not because of theorem 8.9. So keep that in mind as you're trying to answer some of these questions on your own. Okay, now at this point again, go ahead and pause the video and work out these 2 questions and see how you do. And when you're done, hit play and compare your work with mine and see how you did. All right, so let's look at hopefully you have your answers ready. Let's go ahead and take a look at problem 3. What value of x would make the quadrilateral a parallelogram? So we can see again, just like we did in the last example, that we have a diagonal that is bisected already. So we're looking to see what would the other one have to be. So that means 4x minus 7 has to equal 2x, and work that out. So x would have to be 3.5. Well, for 4, if you were paying attention, I've already kind of given you the answer for 4. In the last example, we said, how can I show that this is a parallelogram? And the way the problem set it up was that if I have one set of sides that are parallel and congruent to each other, then it has to be a parallelogram. So I said, well, you could also use distance formula 4 different times to show that it works. We could have also said this answer here. We could have done found the midpoint of the 2 diagonals, and if the midpoint was the same, we could have said that would show me that it's a parallelogram. Or at the very least, I could have even done the slope 4 different times and showed that the opposite sides have the same slope. So that could have also said that we had a parallelogram. So there's more than one way we could have answered that question. So that is pretty much it for this lesson. Previously, we said that if it's a parallelogram, it has these characteristics. Now we're turning it around and we're looking at it from the other way. So I'm just saying now I have a quadrilateral, and I'm trying to see, does it have these characteristics? And if they do, then I can say it's a parallelogram. So that's pretty much it for what we're looking at in this lesson. Any questions that you have, email me, leave me a comment in the Google Classroom, whatever you want to do, let me know. I'll be happy to answer with whatever you have. Until next time, guys, though, thanks for watching and take care.